simplifying one-term expression. So we're looking at expressions. Remember, expressions do not contain an equal to sign, and we're considering ones that only have one term. So I'm going to bring up a few examples, and then I'm going to tell you about how do we solve these types of expressions. So I've got a nice example over here, 81 to the power of 1/4. 81 to the power of 1/4 multiplied by 27 to the power of minus 2 over 3. 27 to the power of negative 2 over 3. Okay, so what do the rules tell us? The rules tell us in order to solve something like this, the first step is we must factorize every base. Now remember, if we go back, we say if I had something along the lines of 2 to the power of 4, then I say that 2 is considered my base. 2 is my base, right? And 4 is my indice or my index, also known as my power, and it could also be called the exponent. Any of these terms are valid, right? And so I'm going to go one back, and let's look at what we have over here. So the rules say number one is I need to factorize all the bases into prime factors. Okay, number one is factorize the bases, or the bases, into prime factors. Okay, and then secondly, the second part just says I need to apply the laws. Apply the exponent or the indice laws. Okay, so let's do this. It means that I need to prime factorize 81, right? And so I'm just going to digress very briefly and show you guys how to prime factorize 81. Well, I look at my prime factors, and what are the prime factors? The prime factors are numbers such as 2, 3, 5, 7, 11, and so on. And when it comes to prime factorization, what I essentially need to do is I need to start with the smallest prime number, such as 2, and see, can 2 go in here? And the reality is that 2 can't really go in here because 81 is not divisible by 2. It's not an even number. So 2 is out of the question. Now I go to the next prime factor, which is 3. And I say, can 3 multiply by anything to give me 81? And the truth is, it can multiply by 27. Okay? And then I start again. I say, can 2 go into 27? And the answer is no. So then I move on to 3, and I say, okay, 3 can go into 27, right? How many times? 9 times. Now I start again with 2. Does 2 work? No. Now I move to 3. 3 works, and I go 3, and then I say, okay, 3 times what gives me 9? 3. And the moment I end up with a number that is actually a prime number over here, I stop. I stop there, right? And I say that 81 is prime factorized into the following. It is 3 multiplied by 3 multiplied by 3 multiplied by 3. I just go along this entire row on the left hand side. And that gives me 3 to the power of 4. So 81 is exactly the same as 3 to the power of 4, and this is considered prime factorized because I'm considering something times something, but the only numbers in my expansion, all these numbers that I see here, they all happen to be prime. Okay, so I'm going to go back, and it says I need to factorize that into prime factors. Okay, so now I do this, and I say, okay, that is equal to the following. That is equal to 3 to the power of 4 raised to the power of 1/4, which is outside, multiplied by 27, and I simplify 27 into its prime factors as well. I could do it over here. I say that 27, okay, can 2 go in there? No, so I go to the next prime factor, and it's 3. 3 times what is it's 9. 3 times 3 gives me this, and I see I stop because this is prime. And therefore I can say that 27 is exactly the same as saying 3 to the power of 3. So let's go back over there, and let's say, okay, this is meant to actually be 3 to the power of 3 raised to the power of negative 2 over 3. Okay, so let's see, what do I really have now? I apply this exponent laws, and the last part is to simply evaluate it. And so let's do that. Let's say, okay, that gives me, the exponent law says if I have this, I need to multiply it by the outside. I need to multiply these two together. And so that's going to give me 3 to the power of 1, because 4 times a quarter is 1, multiplied by 3 to the power of, you need to multiply that exponent 3 times negative 2 over 3, and these two cancels out, so I end up with negative 2. And now I simply see that the bases are identical. The base here is exactly the same as the base there, and so now I can simply calculate this. I say that is 1 minus 2, it's minus 1. And as we know, 3 to the power of negative 1 is 1 over 3 to the power of positive 1. And that is the first example of how to simplify one-term expressions. Remember, this is a single term because there's no plus or minuses separating the term values. Okay, so that's our first example. Factorize the bases into their prime factors. Into what? Their prime factors. And then we apply the exponent laws, as we've done over there. And we end up with this answer. So that's the first example, people.